Okay, so never mind. Okay, so you type GMX underscore MPI.
Tulis lah.
No.
Okay. Underscore.
MPI space. That.
Can I just copy?
Yeah, you can, but you have to change the name of the file.
Okay. Apa tadi? Space ya? Bukan. Tab.
Right click.
Right click. Aduh dah. Okay.
Okay, and then you need to change the name of the file.
This one this one? Oh, what is the file?
The EDR file.
Oh, EDR. Mana EDR?
The only EDR file
Oh
there.
my god. Okay, mana?
Hmm.
Oh, ni. Ya Allah. Okay.
Okay, so is that what you want to name your output file?
No. Mini. Can I just put everything as mini? No,
Yeah, sure, up to you.
Okay.
But you know we are going to generate a few files, right? So you kind of need to know what this means. So if mini, you are looking at the potential energy, right? Like the
Okay, then I
minimization.
will put potential. Okay.
Okay, enter. Okay, you see it gives you a list of options. So that's why it says at the prompt type 11 and 0 to select potential, and 0 terminates the output.
Okay, then
So you type 11 space 0, enter. Okay, so ls. Okay, so you see now you have a XVG file. So this XVG file, you need to use, or you can use XMGrace to plot your graph.
Okay.
Okay, so
Plot graph yang muka.
yeah, you don't really need it lah, but I think at an undergrad level he might ask you to display like what you have learned, but you don't really look
Then
at
the
this.
X grade is we can generate it here.
The problem, I don't think they installed it properly. You can try XMGrace.
Try.
Yeah, you can try XMGrace. If not, what I do is I actually downloaded XMGrace in my laptop.
The only we can only do that by using the XMGrace.
No, you can use it. You can plot it however you want. I think some people plot it with Excel, but this is the most common for MD. Yeah, it's a very, very simple interface.
Oh.
Yeah, so you can type XMGrace.
X.
GRACE space the name of the XVG file. So you can actually just copy also.
Potential.
Okay, enter. Boleh tak? Tak boleh. So you need to export it into your own computer
Okay.
and then visualize it. So I think there are multiple ways you can visualize it. You don't need to download XMGrace, but XMGrace is the most common and easiest. But you can use, some people use Python, some people use Excel. I don't know how they do it. I don't do it that way. So open another terminal. I'll teach you how to move your files. Ideally what I do is I run everything, then I transfer it lah. But kalau you tak sempat and you want to show some result, you can just, yeah, you can show this. Okay, so I think you go into the folder you want to transfer the file to. So which is the name of the folder?
Folder for equilibration. Is it?
Bukan.
No, your folder. Yeah, where do you want to save your...
FYP here.
Okay. Yeah.
Oh, then copy.
Okay. Everything is in here. It's all your you want to keep your file in here.
Oh yeah.
Okay, so you copy the path, the file path. Okay, go back. You enter cd space, enter. Okay, so now you SFTP
SFTP.
your username.
Oh, tadi tu.
Oh, 103.133.195.3. Enter. Then your password. Okay, so what you need to do is you need to enter this, you need to extract potential.xvg. Okay,
Okay.
so what you can do is we want to take the file, so we use get space dot slash md slash the name of your file, so potential.xvg. Space.
Space. Okay, space.
Okay, can you check your folder? Is it there?
Here.
Okay, that's fine. But yeah, that's fine.
Okay.
Usually what I do is I will type a dot after that to specify that this is the folder I want to save it in.
Oh.
Yeah, because the way it works is that when you go back to your terminal, so it should be the command, what you want the program to do, the location of your file, and the target destination of your file. So that's usually how you're supposed to specify it.
Oh.
Yeah. Okay.
Okay.
Okay. Yeah. Now we can close it.
Okay.
Okay. Now, how do you want to visualize your graph?
Maybe by using Excel.
Okay, I don't know how to do that. So
Okay.
you need to Google that.
Alright.
So, you can figure that out, but we
Okay.
can also do the equilibration now.
Oh, okay.
If you want. Wait, what did you come to learn?
Yeah, we are learning this all this code.
Oh, okay. Open back the tutorial.
This one?
Yeah. Okay, click next. Okay, now the equilibration part is a bit more complicated because it's not that complicated, but it depends on what you want. So do you know what parameters you want for your equilibration?
Not yet.
You don't do research
Yeah.
so much because
Okay. Do you have the paper that you're trying to copy from? The
for now we
No.
don't have.
okay. Fine. But how long do you want to run your simulation?
That day doctor asked us to run 10
nanoseconds je.
The 10 kan? 100 kan?
I don't.
Yang 3 kali tu.
I think it's 100.
Yeah.
Could be 100. Yeah. Okay. Because 10 is too short. Okay. So open your equilibration file. So LESS less space step 4.1.
Apa tu? Oh. Apa tadi? Space ke kan?
Enter. Okay. So you see, these are all parameters that you need to adjust now. So this is a time step. So usually we don't use a time step of 1. We use a time step of 2 femtosecond.
Okay.
Because time step of 1 will take you quite long and it's quite unnecessary unless you're doing like very, very like accurate work. It's not necessary for this system. So we will usually change all, well, not all, but the most important parameters. For example, the time step, how long you want the simulation to run, how many times do you want it to print the output, because when you print the output you can also visualize it in your graph. Okay, so and then this one is usually okay, and then you will also adjust the cutoff scheme depending on what you need. Usually I don't touch these things unless you are trying to model after a paper that does specify to change these parameters. Okay, so these are all temperature coupling. Okay, so for example, if you want to, can you go down? Okay, that's the lowest. Okay, yeah, so this is all temperature coupling. So say for example you want to adjust the temperature of your system, you can adjust it here. So this is in Kelvin. Okay, so I mean some people, like one of the girls project I was helping with is 310 Kelvin, so you must change 310. Okay?
Everything is based on what we like the paper say, like the one that we refer, right?
Yeah.
Okay.
Or if it's not necessary to change, you don't have to.
Okay.
You know?
So means we can just follow all here.
You can follow, but a lot of times you must change it because this is the default parameters that ChamGUI gives you. It's not optimized to your structure. It's not optimized for your complex. So, the temperature here, so you must change. So this, doctor told you to run it 3 times, right, for the same structure? Okay, so this is because here at GenSeed, it gives you the velocity, and when you specify -1, it generates random velocity numbers. Okay, so when you run it 3 times, it will give you a new seed number where it runs at different velocity,
Okay.
initial velocity. Okay, so this is something you need to understand what you need to adjust.
Okay.
So if you don't know, or if you're not sure, then you can do something like a standard. For example, this one definitely you change to 0.002, and then maybe, for example, the way you calculate this, right? Okay, let me show you. The calculation for okay, so you see here you can specify the total time that you need for your equilibration. The total time is the dt, which is the time step, multiplied by the n steps. Okay, so here, for example, we have 125,000, and then you multiply it by the time step. So let me open this. So say, for example, time step is 001 multiplied by 125 times 2. So this is going to run for 125 picoseconds. Okay, but if you change your time step, which is more commonly used, 2 femtosecond multiplied by 125, 25,000, you get 250 picoseconds. Okay, so because you are only running for 100 nanoseconds, I think 250 picosecond equilibration is sufficient. So like, for example, my system is 2 microsecond, and that's why I run 10 nanosecond equilibration. Your equilibration step, the duration depends on how long your overall production, your overall simulation run will be. Okay, because the system needs to be comfortable in its environment, because now it has restraints. So at the final production runs, we remove the restraints. Okay, and that's where it needs to properly be in place. Like, it shouldn't be, like, unnaturally, like, flying out of the protein and stuff like that. Does that make sense?
Yes.
Okay, yeah,
Okay.
that's for the equilibration.
And then if let's say I want to run 3 times, meaning I need to do like 3 times, like just now you say I need to change the
Okay,
thing.
so what I recommend you do is, the minimization will be the same.
Okay.
So what I do is I copy the equilibration files,
Mm-hmm.
and I don't change anything unless I'm supposed to change any parameter, but I don't. The only thing that I need to do is start them at different initial velocity. So because we already specify GenSeed -1,
Okay.
it will generate random seed numbers for me already. So the only thing I need to do is continue running from the first equilibration all the way up to the production run. You get it? No. Okay. So when you're done with this, so say, for example, we have 2 equilibration.
Okay.
Okay, this is the first equilibration that specifies the velocity
Okay.
that the proceeding steps will follow.
Okay.
So that means if you want to run another simulation with new initial velocity, you must start from this step.
Okay.
So you can actually just copy, you will take the same parameters and you will run it again for the second
And then-
simulation and run it again for the third simulation. You don't need to change anything if you're only trying to adjust your initial velocity, because GROMACS already does it for you.
Okay.
Got it?
Okay.
Okay. Yeah,
Okay.
that's pretty much it. But you must adjust the parameter according to what you need.
Okay.
Okay,
Ah.
so once this is done, because CharmGUI does not give you the second equilibration file, so we can exit. Okay, let me also teach you. If you want to adjust this file, right, you can use something called Vim, V-I-M. So you can type V-I-M. Space 4.1, step 4.1. Yeah, you can just type. Enter. Okay, so when you type less is actually just to view the file. When you use Vim, you can edit the file. So the way, so Vim actually, right, so the thing with Linux is very sensitive now. So if you delete one thing, it's not in some recycle bin. It's gone. Okay, so, and it's very sensitive as well. So now that you're in Vim, in order for you to adjust the file, you need to type, you need to press I. Yeah. So you see now it has changed to insert. Okay. So now you just use the arrow. You cannot use mouse here tau.
Okay.
You can use the arrow. Like you go down. Say for example you want to adjust this. So you just go all the way here to 1. Okay. You can change it to 2. Okay. So the way you save it will then be you press escape.
Okay.
And you see it has changed. And then you press the colon. That's a semicolon. No, this is the colon. You need to shift and press colon.
Mana boleh tu? Shift. Okay, jap. Kena delete shift dah tu. Soalan.
WQ
WQ.
exclamation mark. So shift and exclamation mark.
Mana way? Which one? Sorry?
Shift and exclamation mark.
Which one? Ni? Ni.
Enter.
Enter.
Okay, so basically what WQ means is write quit. So that means you have written your changes, you have saved your changes, and you quit the program.
Okay.
Okay, so now you can actually view back your file and see if it has changed. So you can press up, the up button, up again. Okay, enter. Yeah, you see, you have already made the changes there.
Okay.
And when you want to exit, less, you just press Q. Okay.
Okay.
Yeah.
Okay.
So now let's create a second equilibration file. So in order for you to create a second equilibration file, you can also use Vim. So VIM. Apa tak ada aku? Okay, wait. Okay, you can. Do you want to name it the same way? Like step 4.2 instead? It's up to you how you want to name. Okay, so you type the name of your file.
This one?
The name of it.
Oh, the new one?
Yeah, like what you want to name your file.
4.2. Apa tadi?
Actually, okay, you can enter.
Oh, okay.
Okay, so this is an empty file. Okay. Press escape. Colon.
Colon. I don't know.
Shift.
Oh,
and
shift.
Oh, colon.
Oh, yang ni.
WQ exclamation mark and enter. Okay, LS. Enter. Okay, you see now you have an empty file here, right?
Okay.
So what I suggest you do is you press next on the equilibration. Okay, just let me pick. Okay, scroll down. Scroll down, down. Oh, okay, So you can click on the file. Try to scroll
Huh?
to the side. Scroll.
On.
Here. Okay, so you see these are the parameters they use for the second equilibration. So this is for pressure coupling.
Okay.
So if you don't have any specific pressure coupling parameters that you are trying to model after, you can actually take the default. Or what I actually do, I actually sometimes check I check GPT what parameters I need for the pressure coupling. But by right, if you have a paper that you're trying to model after, you should take their parameters. You get what I mean?
Okay. Yeah.
Like for example, this one, like this is the paper that I was following. You see this one, isotropic pressure coupling, blah blah blah. Coupling time of 0.1 picosecond, 4.5 by 10.5 bar. So these things are parameters that if you're modeling, you need to be quite specific about it, and you adjust them here. So this is an extra like block of code where you add to your initial equilibration file. Okay. So what I do is yeah, I think you can actually just model after this. So you open back your NVT file, less 4.1, step 4.1. No, less, not a less. 4.1, enter. Okay, let me see how different it is.
This one I should do after I finish my first equilibration.
Yeah, this is the second equilibration. NS type, I don't think you need that. I don't think you need most of these things, except you just need to add actually for this I do recommend you add the periodic boundary conditions as well. But I think essentially what you need is you just copy from the pressure coupling. So all this part you copy and put it into the script. So okay, let me not make it confusing. Copy the script. So you just click on it.
Then,
Without the end.
oh, yeah.
Right click.
Wait.
Okay. Exit this. Q. Okay. Vim. VIM. Step 4.2. Space. Enter. Okay. Press I to insert. Right click. Okay. So from here, include this block.
Then I should copy him.
Yeah, you can use copy.
Until velocity.
Velocity tak ya? Velocity because Gen val is already here.
Okay.
All you need to do is you need to copy this first.
And then
You click on the screen. Yep. Okay. Up. Enter.
here.
Press enter. Paste. Okay. I mean you can delete whatever is after this.
Okay. Oh, I can read it now.
Preferably.
Okay. Wait.
These are all extra comments, so you just remove them. Okay, I need to move this.
Oh.
This one is a comment. You don't need it, but you can keep it. Okay. Fashion properties. Okay, so you see what happens here is that this is the for the velocity. You don't want it to generate new velocity because at an NPT stage you must use the velocity that was used in the first equilibration. So the first equilibration is called NVT, second equilibration is called NPT. So what you do is you specify no. No, we do not want new velocity. And then just like how you see here, right? Gentem tak ada kan? Ada ke? Okay, so whatever that is not there, you can remove it. Like this one, we don't want this. And we definitely do not want this, because this means that it will generate new velocity and we want to maintain the same velocity. Okay, so now we will check the overall file. New process, the reference is the same. Okay, I think it should be okay. Okay, so then you save the file. So you press escape, colon, WQ, exclamation mark, enter. Okay, next you fix or you adjust your production file. So once you have adjusted all these files, you can proceed to run your equilibration and then your production run. Okay, so adjust your step 5 underscore production file. So VIM step 5, enter. Okay, you want to do 100 nanosecond, correct? So you see how the time step has already been adjusted, 0.02. So now what you need is you need to know how many steps. So how many steps do you require to reach 100 nanosecond? So 0.5. Okay, so what you do is 0.002 divided by, oh my god, what is 100 nanosecond? 100 nanosecond is how many picosecond? Sorry guys. Shit. Sekejap. So total time is equals to dt times n steps. But I want to know how many n steps to take. So that would mean 100,000 divided by 0.02. So you mean 100,000 divided by 0.02. So you need 50 million steps. Is that correct? Wait on. So this is 1 nanosecond. Betul lah. Okay, so the calculation is like this. So, the total time equals to the time step multiplied by the n steps. Okay, so you have 100 nanoseconds and you want to know how many n steps you need. So you divide it by the time step. So the time step is 0.002. So you want, by the way, everything is calculated in picosecond here. So you must convert to picosecond. I just don't want the math now. So 100 nanosecond divided by 0.002. This is the number of n steps you need to specify in here. So you need to change the n steps. So you have to press I. Okay, so go to n steps. Okay, so you need to make it 50 million. You can actually add commas and then remove it later, like because I sometimes I miss the numbers too. Okay. Correct. Okay, then you remove the commas. Okay, and then again, like all of these other things, you should adjust according to what you need for your production run. But one interesting thing to note is that if you look at the equilibration files, right, there's always one header up here that says like dpos_res. So that, like for example macam ni, dpos_res. So that means that it is restraining the file. When you do production run, you must actually make sure that there are no restraints. There are rare cases where like your experiment requires you to restrain, but most of the times it doesn't, because it should follow the natural trajectory or the movement of the complex in its natural environment. So that's why we don't restrain. Okay, so now you save the file. Escape colon WQ exclamation mark, enter. Okay, that's all you need to do. Now you just need to run your equilibration. So when you run your equilibration, I highly recommend you you screen it. Okay, so when you go back, okay, so you scroll down, go back.
This one?
Yeah. Okay, so when you go down, okay, so so you see how the first run will generate a TPR file for you, and the second run, when you see MD run, that is when the program is actually running your minimization or your equilibration or your production run. So when you are trying to generate the TPR file, you can just run it here. But when you start running the actual process, the equilibration or the production, I highly recommend you do it in screen. Okay, like you screen -s, type the name of your screen, so that it can run in the background. And when you want to exit your screen, right, so let me just quickly teach you. Type screen, dash capital S, space. You name it, I don't know, NVT, equilibration, anything. You can name it whatever you want. T. No.
Ya, benda ni.
Okay, enter. Okay, so now that you're here, you can run the command here. And okay, we can do the first one.
Okay.
Okay. So let's generate the TPR file. You can generate in the main screen or you can generate here, so it's fine. So gmx underscore MPI, and then you just follow the command.
For the first one or the second one? This one?
Yeah.
Oh, okay.
You need to adjust it according to the name of your file.
oh,
Yeah.
okay.
If you don't know the name of your file, what you can do is you type ls and look back at the names of your file.
Okay. But CMX
MPI.
MP
M.
M. Lepas tu masa ni tadi mana? Import MPT ni mana tu?
4.0. Step 4.0.
Ni kan?
Hmm.
Lepas tu EM EM apa ni? Oh, minimization kan?
Hmm.
Lepas tu EM Chrome. Okay, lepas tu MVT. Okay. Tadi besar ke kecil?
Besar.
Besar.
We didn't do the NVT like this one. We did minimization je kan? Okay, enter. Okay. So now you can run your equilibration. So gmx underscore MPI space md run. Yeah. Okay, so I recommend that you add a dash v. So v means to visual. No, space. Okay, dash v space, and then you do the. So I recommend that you put dash v because v means to visualize the progress of your process, whatever it is, whether it's equilibration, minimization, production.
After the M run. Okay.
When you put NVT, like you have to make sure that that is the name of the file that it needs to search. Is it? Is that the only name of it before the dot?
Yeah, I think yes.
Okay, then you can press enter.
Yang just now yang
Mm.
tambah tekan lah.
Okay. Why is it oh my god. Okay, I see the problem. Can you press up? Up. Right. So instead of running your NVT, you have run another minimization, which is wrong. So by right, this file should be your equilibration file.
Oh. Okay. Then I need to change.
Okay, so why don't you delete your NVT? Yeah. Okay, delete your TPR nvt.tpr. No. Okay, delete the whole command. Press ls. Okay, so you see this TPR file, and technically whatever TPR file is here, you cannot use because it is now a minimization file instead. So remove all NVT files. So rm space dash R space NVT,
The capital.
yeah, and then star. Okay, so what this command actually says is that you must remove all files that start with NVT. Enter. ls. Okay, so you see we have removed all of these. Now run back this exact command, but fix them according to your the files that you need.
MBI.
MP. MM.
Right?
No. So when you put, basically what this is saying is that this is the name of your file, but this is because it is in a folder where this file is present, but you are already in the folder where your file is present, so you change it to the name of your file only.
NVT.
No, it's the input file. So you see, notice here it is .mdp, right? So which MDP file is referring to your equilibration command? It is step 4.1.
Then I need to delete
Yeah,
together with the input, right?
yeah,
Okay.
because you don't have an input folder.
Done. MDF tu. Sampai ni.
Betul ke yang EM tu nak tukar dengan minimization?
Yeah.
Ini apa? NVT besar.
Dia ke? Tapi kena mana?
You can actually keep it as small letters. It's honestly easier to type. But you must put the file extension. Enter. Okay, so when it comes up like this, right, it says it is not found in the list of index groups. So you type ls, enter. So what I want to show you is that we have something called an index file. An index file will tell you the groups, how the atoms are grouped in the structure. So sometimes GROMACS is not able to read it and it needs a supplementary index file with the command to read. So press up again. Okay, so go back. So before the output, you need to specify -n
Here.
space index.ndx. So you specify the file. Space, enter. Okay. So then you run your equilibration. MPI. I suggest you put -v also.
Dash.
But before the D, E, F, and M.
Oh, okay.
-v. Enter. This is gonna jam up the server actually. This one will finish tomorrow. You see, this timing is actually US timing. So while it says December 5th today, right? What it actually means is tomorrow.
Oh.
But this is considered slow actually, but right, it shouldn't be like this. So now what you can do is you exit the screen. So you no, you control AD.
AD.
Control and AD together, all together.
Oh.
So you see detached. So what you have done is that, think of it like when you open a browser, right? You buka banyak-banyak tab. And I ran something in one tab. So all I need to do is I minimize it. That's literally what you have just done with the screen. This is the concept of screens in Linux. Okay? So, you say for example, you have already opened banyak-banyak screen and you want to go back into these screens. So in interface, you can just click, right? So in Linux, you can check. The way you check is, you type screen, space, ls, enter. Okay, screen, space, dash ls, enter. Okay, so you see this is the name of your screen. So if you want to reattach back the screen, if you have only one screen running, you can actually type screen,
Oh, okay.
space, dash r, enter. That's if you have one screen. So so Linux immediately knows what screen to grab. But if you want to pick a specific screen, okay, so let's detach again. So whenever we want to exit the screen, we have to detach, okay, so that the process still runs. So you control AD, okay, you type screen, space, dash r, space, copy the name here, enter. Okay, so you enter back the screen. So this is helpful when you have multiple screens running.
But then I cannot see like the time like just now.
What time?
Just now like they got write Friday blah blah blah. But in here I cannot see the thing.
Cuba expand.
Huh?
Expand it.
This one?
Yeah. Not yet. I think you need to.
So now
You
they are
wait
running.
for a bit. Yeah, now this is the first equilibration. So the way you do it, you must finish this equilibration for you to do the second equilibration, and then do the production run.
Okay.
So lama.
It's actually not long. It's just the server is full and people are not queuing up properly. Technically, we are doing the same thing, but that's because other people are getting considerate. Apa I cakap? What you can do in the meantime is, I suggest you do this one first, okay? Because there is no space in the server, and you extract your minimization and do the graph. And once this equilibration is done, you can also do like the potential energy mapping as well. And then you continue your second equilibration, then continue your production run. And once that is done, then you do your second replicate. Okay? Yeah. You could run all together, but most likely it's not going to finish on time. So you see, sometimes it needs time to calculate, and then it says again, it's going to finish in 5th December.
Okay.
So you detach from this screen, and then you can close it if you want.
Oh,
Yeah. So it will run in the background. Yeah.
Okay.
So there are multiple ways of doing this. This is the most recommended way that has been taught to me. Yeah. So does that make sense?
Yeah.
Okay.
Okay.
Yeah, that should be it.
Okay.